Hypoadrenocorticism is also called Addison's disease, and typical Addison's is a condition where both glucocorticoids and mineralocorticoids are deficient. There are three types of Addison's. One, atypical, where only the glucocorticoids are deficient. Two, typical Addison's, where both glucocorticoids and mineralocorticoids are deficient. And three, iatrogenic Addison's, where, for example, surgical removal of a neoplastic adrenal gland is not followed by a correct or the correct post-operative care, or prolonged treatment with a steroidal anti-inflammatory drug like prednisolone is not stopped correctly. In both cases, the atrophic adrenal or adrenals is or are not given the time to eutrophy. Hypoadrenocorticism is the phenotype of decreasing hormone production by the adrenal cortex. I emphasize decreasing because typical presentation of these patients start with signs of decreasing glucocorticoid production, which then encompasses mineralocorticoid production. This is reflected in the phenotype by a waning and waxing presentation where the dog comes in not feeling well and the vet gives it prednisolone, which is a glucocorticoid, and the dog recovers, is sent home, comes in again, and the same happens, and finally when it is presented in Addisonian crisis. The waxing and waning pattern is typical of adrenal-dependent Addison's, which always ends up affecting the whole cortex. In secondary Addison's, which is pituitary dependent, where there is a deficiency of ACTH, the phenotype presents as atypical Addison's in that it is the hormones produced by the zona fasciculata, which are glucocorticoids, and zona reticularis, the sex steroids, that are under ACTH control and therefore deficient. Hormone secretion by the zona glomerulosa is controlled by the renin-angiotensin-aldosterone system. ACTH deficiency does not precipitate aldosterone deficiency. Thus, the mineralocorticoid effect remains intact. The function of aldosterone is to defend total sodium in the ECF, hence in the body, at every exit point. That is in the nephron, the GIT, salivary glands, sweat glands, etc. This is accomplished through exchange with potassium and or hydrogen ions. Chloride ion follows sodium ion. Thus, a deficiency of aldosterone will present the following ionic phenotype: hyponatremia, hypochloremia, and hyperkalemia, with the attendant complications of hypovolemic shock with bradycardia and a typical ECG showing absent or prolonged P wave, wide QRS complex with reduced R wave amplitude, and tented T waves. The hypovolemia is due to osmotic diuresis due to natriuresis, and this is accompanied by polydipsia. This picture is also associated with muscle weakness and lethargy, GIT bleeding, and an animal that cannot withstand even light, stressful situations.